Lesson 4 is on solving exponential equations. Now you might be thinking to yourself, we already did that. And you're right, we did. We solved exponential equations if we could find, a common base. So if we can't find a common base, then that's what we're going to be learning how to do today. So first off, just a quick review how to solve with a common base. Well, you need to find a way to write both sides of the equation with the same base. So 2 to the power of what equals 32? You can try typing it in on your calculator and you'll get 5. And then once those are the same, you drop the bases and you are left with usually an equation to solve, but not in this case. In this case, we just had our answer, x equals 5. Okay, the next one, I see my common base is going to have to be 2. I can rewrite 4 as 2 to the power of 2, and then that x has to stay there. Okay, now that I have the same base, I can drop them, and I'm left with 2x equals x plus 3. And now I solve the equation, subtract x from both sides, x equals 3. Okay, always check your answers as well. So what we're doing today is we're solving when you cannot find when you cannot find a common base. So there's two different methods. We're going to focus primarily on 1 and 3. 1 is how you're going to be expected to solve it on the diploma when it says solve algebraically. So 5x equals 200. The first method is to convert it to logs. So thinking back to how to convert it, the base of my exponent becomes the base of my log, so 5. The 200 is there, and then the x is on the other side. So always check it. The g kicks the 5 over, which pushes up the x, and make sure you have what you started with. So now we have essentially log 5 of 200 equals x. So remember to type that in on our calculator. We take log of 200 and then divide it by log of 5. And that'll equal x. So x equals 3.29 rounded. So method 3 is similar to what we have seen in the past. You're going to set the left-hand side equal to y1 in your calculator, and you're going to set the right-hand side equal to y2. And then you find the intersection, and you'll find the same answer, x equals 3.29. All right, we're going to skip method 2 for now and come back to it after. Okay, so example number 1. Use the two methods to solve the following equations to the nearest hundredth. So change to logs. Base of my exponent becomes the base of my logarithm, and the exponent becomes my answer. Okay, to type that into my calculator, log 54 divided by log 3 equals x. Okay, the answer for that one is 3.63. It said solve to the nearest hundredth. Nearest hundredth is 2 decimal places. Okay, I'll show you the use equation rules. I'll even write down the steps. The first step is to log both sides. So in this case, we take the log of 3 to the power of x and the log of 54. That's what it means to log both sides. After that, you're going to use your exponent laws and bring the x down. So opposite of what you did yesterday. It now becomes x log 3 equals log 54. And then to get rid of the log 3 and just have the x, we just divide by log 3. And on this side, they cancel out, and we're left with x equals log 54 divided by log 3, which, lo and behold, is what we had over on this side as well. So x equals 3.63. All right, next example. Getting a little bit trickier. We have to add a step in at the beginning, which says isolate the power, and then solve for x. So isolate the power means that this 4 is on the wrong side, and we need to move it. So I need to subtract 4 from both sides first. I get 8 to the power of x equals 36. Now I convert it to logarithmic form. And I solve for x. Okay, the answer for that one is x equals 1.72. All right, next one, we still have to keep in mind that we have to isolate the power first. In this case, this here is my power, just the 2 to the power of x. Everything else needs to be moved. So I'm going to move the 3 to the other side by first dividing by 3. So I now have 100 divided by 3. I'm going to leave that as a fraction equals 2 to the x. Now I can convert it to logarithmic form. Log base 2 of 100 over 3 equals x, and solve for x. X equals 5.06. All right, example 2, fairly similar, but now we have to add one more step in. So first, convert it to logarithms. We have log base 3 of 20 equals x minus 1. Sorry, I'll get rid of this equal sign here. Then from there, you're going to actually figure out what log 3 of 20 is by taking log 20 and divide it by log 3 on your calculator. So that's 2.73. So we get 2.73 equals x minus 1. And now we have to add 1 to both sides. And we get x to be equal to 3.73. So just that extra step of adding 1 or doing whatever opposite operation you have to do. Okay, the next one we have log base 5 of 104 equals x plus 2. I find out what that number is. That number is 2.89. And then I solve for x by subtracting 2, and I get 0.89 equals x. All right, it is your turn to practice. Please go to lesson 4 worksheet and complete the odd questions.